Hi guys, welcome back to Bio Breakdown. Today we are diving into one of the coolest parts of the human sensory system, which is how your eyes manage to focus on almost anything around you, whether it is your phone right in front of your face or a taxi speeding down the road in the distance. The truth is, your eyes are constantly adjusting even though you don't feel any of it happening, and that whole process is called accommodation. Accommodation basically means the eye is changing the shape of the lens to make sure the image always lands sharply on the retina, which is the light-sensitive layer at the back of the eye. When you look at something far away, like a mountain, a signboard, or someone waving from across the field, the ciliary muscles relax, the suspensory ligaments tighten, and the tension on the lens increases. This makes the lens flatter and less convex, which means it bends the light less so the rays can focus perfectly on the retina. But the moment you shift your focus to something close, like reading a WhatsApp message, sewing a button, or checking a price tag in a shop, everything changes. The ciliary muscles contract, the suspensory ligaments loosen, the tension on the lens decreases, and the lens becomes rounder and more convex. A rounder lens bends the light more strongly, helping the image land exactly where it needs to on the retina so you can see nearby objects clearly. Along with the lens, the pupil also works non-stop to manage how much light enters the eye, and this whole system is called the pupillary mechanism. The iris controls the pupil using circular and radial muscles that work together, but in opposite ways. When you step outside into bright sunlight, the circular muscles contract, the radial muscles relax, and the pupil becomes smaller. This protects the retina from too much light, similar to pulling a curtain halfway closed when the sun is too bright. When you walk into a dim room, the opposite happens. The radial muscles contract, the circular muscles relax, and the pupil widens so more light can enter, allowing you to see better in low light. Once you understand these mechanisms, visual defects suddenly make a lot more sense. Short-sightedness, or myopia, happens when a person can see close objects clearly but struggles with distant ones because the light rays focus in front of the retina instead of on it. This often happens when the eyeball is slightly too long or when the lens bends the light too strongly. Concave lenses correct this by spreading out the light rays so the focus moves back onto the retina. Long-sightedness or hyperopia is the opposite. Distant objects look clear, but nearby objects appear blurry because the light focuses behind the retina. This can happen when the eyeball is too short or when the lens cannot become round enough. Convex lenses fix this by bending the light inward so the image falls exactly on the retina. Astigmatism is another common problem. It occurs when the cornea or lens is unevenly curved, which makes light focus in different places instead of at one clear point. This leads to blurry or distorted vision, headaches, and squinting, especially when reading or trying to look at fine details. Special lenses, contact lenses, or laser treatments can correct this by changing how the light enters the eye. Cataracts are a different kind of issue. They happen when the lens becomes cloudy and blocks light, causing vision to look foggy or washed out. Cataracts develop slowly, and while stronger glasses might help at first, the long-term solution is surgery. During surgery, the cloudy lens is removed and replaced with a clear artificial one that works almost like a natural lens. Understanding all these processes helps you see why optometrists choose specific lenses and why different eye conditions need different treatments. Thanks for watching, and stay tuned for more simple and surprisingly cool life sciences explanations right here on Bio Breakdown.